everyone. In the last session we learned how to evaluate a double integral. Now in this session we are going to learn how to evaluate a triple integral. So let us solve problems on triple integral. Evaluate triple integral xy square z dz dy dx between the limit 0 to 2, 1 to 3 and 1 to 2. So consider the given integral as I. I is triple integral of xy square z dz dy dx between the limit 0 to 2, 1 to 3 and 1 to 2. So before going to integrate, we should know what is the limit of x, y, z. Since here in the given problem, all the limits of the integrals are constant, we can split the triple integral as a multiple of line integrals. I can separate the integrals for x and integral for y and integral for z. Whenever we have only the constant limit, if we have a variable limit, then we can't split the integral. So before going to split, the inner integral limit stands for z because we have dz here. Then the second one is for y varies from 1 to 3, and then outer limit with a x limit, that is x varies from 0 to 2. So I can write this as integral 0 to 2 x into dx into integral 1 to 3 y square dy into integral 1 to 2 z dz. Now integrate x with respect to x, that is x square by 2 between the limit 0 to 2 into integral of y square is y cube by 3 between the limit 1 to 3 into integral of z is z square by 2 between the limit 1 to 2. Now apply the limit 1 by 2 common, upper limit 2 square minus lower limit 0 into 1 by 3 times of upper limit 3 cube minus lower limit 1 cube is nothing but 1 into 1 by 2 times of upper limit 2 square minus lower limit 1. Now if I simplify this, we have 1 by 2 times of 4 into 1 by 3 into 3 cube is 27. 27 minus 1 is 26 into 1 by 2 into 2 square 4. 4 minus 1 is 3. So I can cancel 3 and also 2 into 2 4 and numerator value 4 get cancelled. So the given triple integral value of the result is 26. Now solve the second one. Evaluate triple integral of e to the power of minus of x plus y plus z dx dy dz between the limit 0 to infinity, 0 to infinity and 0 to infinity. All the limits are between 0 to infinity. So consider the given integral as I. I is triple integral of, instead of having e power minus of x plus y plus z, I split the power like e power minus x into e power minus y into e power minus z dx dy dz, and of course the limits are 0 to infinity, 0 to infinity. Again all the limits are constant limit. As we solved in the first problem, we can split the triple integral as a multiple of 3 line integral, that is integral 0 to infinity e power minus x dx into integral e power minus y dy between the limit 0 to infinity integral e power minus z dz between the limit 0 to infinity. Now integrate. We know the integral of e power ax is e power ax by a. So in place of a we have minus 1. So integral of e power minus x is e power minus x by minus 1 between the limit 0 to infinity. Integral of e power minus y is e power minus y by minus 1 between the limit 0 to infinity. Integral of e power minus z is e power minus z by minus 1 between the limit 0 to infinity. Now apply the limit minus 1 common, upper limit infinity, lower limit 0, e power minus infinity minus e power 0 into minus 1 common, upper limit e power minus infinity, e power 0 into minus 1 times of e power minus z minus e power 0. Now simplify this. We know that e power minus infinity is 0. So we know that e power minus infinity is 0. E power minus infinity value 0 and e power 0 value is 1. So minus of minus become plus 1 into again the same thing plus 1 into minus of minus 1 is plus 1. So the result is 1. So the evaluated result of the given triple integral is 1. Now next problem, evaluate triple integral r square sin theta d pi d theta dr between the limit 0 to a, 0 to pi by 2 and 0 to pi by 2. R square sin theta d pi dr d theta. Right? So consider the given integral as I. I is triple integral of r square sin theta d pi d theta into dr. So the limits are 0 to a, 0 to pi by 2 and 0 to pi by 2. So instead of x and y, in the previous two problems we have x and y and z as a variables, right? Now here we have in a polar form, that is r, theta and pi. So we know that theta and pi are angles and r is of course a radius, right? So your r limit stands between 0 to a, whereas theta and pi varies between 0 to pi by 2. And of course here also we have a constant limits. All the three limits are constant. Therefore, I can split the triple integral as a multiple of Lyell integral as we solved in the previous two problems. So integral 0 to a r square dr. So a limit 0 to a stands for variable r, whereas theta and pi varies between 0 to pi by 2 sin theta d theta into integral of d pi between the limit 0 to pi by 2. Now apply the or integrate the, now integrate with respect to r, theta and pi, that is integral of r square is r cube by 3 between the limit 0 to a into integral of sin theta s minus cos theta between the limit 0 to pi by 2 and integral of d pi is pi between the limit 0 to pi by 2. Now apply the limit 1 by 3 common, upper limit a cube minus lower limit 0 into minus 1 common, cos pi by 2, theta should be replaced by pi by 2 minus cos 0 into pi by 2 minus 0. Upper limit minus lower limit. So we left with a cube by 3 into cos pi by 2. We know that cos pi by 2 is 0 and cos 0 is 1. So minus of minus plus 1. So the second value is 1 and the last one is pi by 2. So the given triple integral final answer is pi a cube by 6. So our next problem is evaluate triple integral of x square plus y square plus z square dz dy dx between the limit minus c to c minus b to b minus a to a. So of course, as we solved in the last three problem, we have again a constant limit. A, B, C are constant limit. But as we split in the last three problem, here we can't split because we have sum of the variables, that is x plus x square plus y square plus z square we have. So we can split the triple integral whenever we have a product of the functions or a variables. If we have a sum or the difference, then we can't split the triple integral as a multiple of line integral. So we should solve one by one. That means first we should integrate with respect to z, then with respect to y, then with respect to x. So consider the given integral as I. I is triple integral of x square plus y square plus z square dz dy dx between the limit minus c to c minus b to b minus a to a. So of course, since I have dz here, so z limits varies or z varies from minus a to a, then we have dy, therefore y varies from minus b to b, and then x, therefore x is a outer integral, that is x varies from minus c to c. So first integrate with respect to z, keeping x and y as constant, that is integral minus c to c, integral minus b to b, x square constant, integral of dz is z between the limit minus a to a plus y square constant, integral of dz is z between the limit minus a to a plus z square integration z cube by 3 between the limit minus a to a, and dy dx remains as it is. Now apply the limit minus c to c integral, integral minus b to b x square into upper limit a minus lower limit minus of minus a plus y square into upper limit a minus of minus a, that is lower limit, plus 1 by 3 into a cube minus of minus a whole cube dy dx. Or if we simplify, triple integral minus c to c, integral minus b to b, a minus of minus a become plus a. So a plus a is 2a, 2a into x square is 2a x square plus a minus of minus plus a again plus a, and a plus a will be 2a. So 2a into y square is 2a y square plus 1 by 3 times of a cube minus of minus a whole cube. So minus a whole cube is nothing but minus a cube again. Therefore we have minus of minus plus a cube. So a cube plus a cube will be 2 times of a cube. So 2 times of a cube by 3 into dy dx. So we eliminate with a z variable, we left with x and y, right. Now integrate with respect to y, keeping your x constant, that is integral minus c to c 2a x square constant, integral of dy is y between the limit minus b to b plus 2a constant, integral of y square is y cube by 3 between the limit minus b to b plus 2a cube by 3 constant, integral of dy is y between the limit minus b to b into dx. Now as we solved in the z, once we integrate with respect to z, we apply the limit in the same way, apply the limit, upper limit and lower limit, and simplify, then integrate with respect to x. So I is equal to integral minus c to c 2a x square into upper limit b and lower limit minus of minus b plus 2a by 3 common upper limit b cube minus of minus b whole cube plus 2a cube by 3 into upper limit b minus of minus lower limit minus b into dx. Now simplify and then integrate with respect to x. So b minus of minus plus b, it becomes 2b. So 2b into 2a is 4 times of ab x square. B cube minus of minus b whole cube. Minus b whole cube is nothing but minus b cube. So minus of minus become plus b cube. B cube plus b cube will be 2 times of b cube. So we have 4 times of a cube by 3. 4 times of a into b cube by 3 plus again b minus of minus plus b. So we have 2b. 2b into 2a cube is 4 times of a cube b by 3 into dx. So we remains only with the x variable and we eliminate with x, y and z. Now integrate with respect to x, that is minus. So we remains with only x variable. We eliminated with y and z variable. Now integrate with respect to x. So 4ab constant, integral of x square is x cube by 3 between the limit minus c to c plus 4ab cube by 3 constant, integral of dx is x between the limit minus c to c plus 4a cube b by 3 constant, integral of dx is x between the limit minus c to c. Now apply the limit. 4ab by 3 common, upper limit is c whole cube minus of minus c whole cube plus 4ab cube by 3 into upper limit c minus of minus c is the lower limit, and the last one plus 4a cube b by 3 into upper limit c minus of minus c, that is the lower limit. Now simplify. So we have minus c whole cube. Minus c whole cube is nothing but minus c cube. So minus c cube into minus is become plus c cube. So c cube plus c cube is 2 times of c cube. So 4 into 2 is 8ab into c cube by 3 plus c minus of minus plus c, 2 times of c we have. So 4 2s are 8a b cube c by 3, and the last term is c minus of minus plus c is again 2 times of c. So 4 into 2 become 8 times of a b. So we have, so in the last term we have 4a cube b by 3 into 2 times of c. So 4 into 2 is 8a cube b c by 3. Now in all the 3 terms we can take out 8abc common, 8abc by 3 common. Therefore take out 8abc by 3 common. Then we remains in the first term c square. In the second term, yes, we remains with b square, and in the last term we remains with a square. Therefore the evaluated result of the given triple integral is 8abc by 3 into c square plus b square plus a square. That's our answer. Next problem, evaluate triple integral dz dy dx between the limit 0 to 1, 0 to 1 minus x and 0 to 1 minus x minus y. So consider the given integral as I. The given triple integral is I is triple integral of dz dy dx between the limit 0 to 1, 0 to 1 minus x and 0 to 1 minus x minus y. Now, in this problem, we have a variable limit. In the place of limit, we have variables. So, in the last problems, we have only a constant limit. So, we integrate. Now, we have variable limit. So, we should consider the limit of a dz as inner limit. That means z varies from 0 to 1 minus x minus y, because in a limit place we have both x and y. So, since I have both x and y in a limit place, that should be a limit of z. Z varies from 0 to 1 minus x minus y. Then in the second integral, we have a limit between 0 to 1 minus x. Since we have x in a limit place, that must be the limit of a y variable, that is y varies from 0 to 1 minus x. And in the last or the outer integral, we have a constant limit, so that stands for x. So, your x varies from 0 to 1. So, whenever we have x, y in a limit place, then that must be a limit of z variable. Okay, and if z is completed, then if I left with the x in a limit place, then that must be a limit of y, and the constant, of course, it's a x limit. Now integrate one by one, first with respect to z, then with respect to y, and then with respect to x. So keeping x and y constant, we must integrate with respect to z. So I don't have any function there, I have only dz. Therefore integral of dz is z between the limit 0 to 1 minus x minus y dy dx. Apply the limit, integral 0 to 1, 0 to 1 minus x, 1 minus x minus y, upper limit, minus lower limit is 0, dy dx. Okay, or it reduced with 0 to 1, integral 0 to 1 minus x, 1 minus x minus y, dy dx. Now, keeping x constant, integrate with respect to y, that is integral 0 to 1, integral of dy is y between the limit 0 to 1 minus x minus integral x constant, integral of dy is y between the limit 0 to 1 minus x minus integral of y is y square by 2 between the limit 0 to 1 minus x dx. Now apply the limit. I is integral 0 to 1, upper limit 1 minus x minus lower limit 0 minus x into upper limit 1 minus x, lower limit 0 minus 1 by 2 into upper limit 1 minus x whole square minus 0 dx. Now simplify and then integrate with respect to x, that is integral 0 to 1, 1 minus x minus, I can multiply x with 1 minus x, that is x into 1 x minus of minus plus x into x, x square, and I can expand this 1 minus x whole square using a minus b whole square formula, that is 1 plus x square minus 2x, right. So I can multiply by minus 1 by 2 now, that is minus 1 by 2 into 1 is minus 1 by 2, minus into plus minus x square by 2, minus into minus plus 2x by 2 reduces to x dx. Now simplify before going to integrate, that means I can cancel minus x plus x here, and I can add or subtract these two values, that is 1 minus 1 by 2, integral 0 to 1 by 2, 0 to 1, 1 minus 1 by 2 is 1 by 2, okay, minus x, and I can simplify these two, of course. We have 1 times of x square and minus 1 by 2 times of x square is nothing but 1 minus 1 by 2 is plus x square by 2 dx. Now we remains with only x variables. Now integrate with respect to x, that is 1 by 2 constant, integral of dx is x between the limit 0 to 1 minus x integration is x square by 2 between the limit 0 to 1 plus 1 by 2 into x square integration x cube by 3 between the limit 0 to 1. Now apply the limit 1 by 2 into 1 minus 0 minus 1 by 2 common, upper limit 1 minus lower limit 0 plus 1 by 6 into upper limit 1 lower limit 0. So we remains with 1 by 2 minus 1 by 2 plus 1 by 6. Therefore, the required result is, I can cancel plus 1 by 2 minus 1 by 2, right? So we left with 1 by 6 as our result. Next problem, evaluate triple integral x plus y plus z dy dx dz between the limit minus 1 to 1, 0 to z and x minus z to x plus z. So consider the given integral, triple integral as I. So I is triple integral of x plus y plus z dy dx dz between the limit minus 1 to 1, 0 to z, x minus z to x plus z. Now what is the limit of y and limit of x and limit of z? So the inner integral limit place, in inner integral limits we have x minus z to x plus z. That means x and z variables are in the limit place. Therefore, as I told you in the last problem, that should be the limit of y. So y varies from x minus z to x plus z. Then in a limit place we have a z. Therefore, that should be a limit of, yes, that should be a limit of x. And also here we have dx in a second place. Therefore, the second integral is x limit. X varies from 0 to z. Then the outer integral limit stands for z. Z varies from minus 1 to plus 1. Now keeping your x and z constant, we should integrate with respect to y. So integral minus 1 to 1, integral 0 to z, keep your x constant, integral of dy is y between the limit x minus z to x plus z plus integral of y is y square by 2 between the limit x minus z to x plus z plus z constant, integral of dy is y between the limit x minus z to x plus z dx then dz. Now apply the limit, integral minus 1 to 1, 0 to z, x into upper limit x plus z minus lower limit, that is minus of x minus z plus 1 by 2 common, upper limit x plus z whole square, we have minus lower limit x minus z whole square plus z into upper limit x plus z minus lower limit x minus z dx then dz. Now simplify, that is integral minus 1 to 1, 0 to z. So if I simplify this, like we have x plus z minus x plus z we have. If I multiply by minus sign, then plus x minus x get cancelled. We remains with z plus z 2z. So 2z into x will be 2 times of xz plus 1 by 2 times of, here we have a plus b whole square and a minus b whole square. I expand here, x square plus z square plus 2xz minus of x minus z whole square. So I multiply by minus sign and also I expand a minus x minus z whole square. that is x square minus z square, minus of minus become plus 2xz. So we can cancel here plus x square and minus x square, and also we can cancel plus z square and minus z square. So we remains with 2xz plus 2xz is nothing but 4 times of xz. 4 times of xz divided by 2 is 2 times of xz. So the second term simplified value is 2 times of xz. And the last one again. So x plus z minus x minus of minus plus z. So I can cancel plus x and minus x. We remains with z plus z. Z plus z is 2z. 2z into z. Yes. 2z square dx then dz. Now keeping your z constant, integrate with respect to x, that is integral minus 1 to 1, 2x is constant, integral of z is z square by 2 between the limit 0 to z. Now keeping your z constant, integrate with respect to x, that is integral minus 1 to 1, 2z constant, integral of x is x square by 2 plus 2z constant, integral of x is x square by 2 plus 2z square constant, integral of dx is x between the limit 0 to z, 0 to z and 0 to z dz. Now apply the limit and then integrate with respect to z. So the given integral I reduces to 2 get cancel, integral minus 1 to 1 z into upper limit z, we have x square, so that becomes z square minus lower limit 0, 2 get cancel plus z into upper limit z square and lower limit is 0 plus 2z square into upper limit z minus lower limit 0 into dz. Okay. Now simplify this. Minus 1 to 1 z into z square is z cube plus again z into z square we have z cube plus 2z square into z, that is 2 times of z cube dz. So I can add before going to integrate. Minus 1 to 1 integral minus 1 to 1 z cube plus 2z cube is nothing but 4 times of z cube into dz. So we remains with only z. Now integrate with respect to z, that is 4 common, integral of z cube is z power 4 by 4 between the limit minus 1 to 1, between the limit minus 1 to 1. Now 4 get cancel, upper limit 1 to the power of 4 minus lower limit minus 1 power 4. So that is 1 minus 1. So the given triple integral value is 0 because minus 1 to the power of 4 is 1. So 1 minus 1 remains with 1 minus 1. 1 minus 1 is 0. Now evaluate triple integral of e power x plus y plus z dz dy dx between the limit 0 to a, 0 to x and 0 to x plus y. So consider the given integral as I. So I is triple integral e power x. I split the sum of the power as a multiples, that is e power x into e power y into e power z into dz dy, and the limits are 0 to a, 0 to x and 0 to x plus y. So again we should know what is the limit of x, y, z, right? So since we have dz here, and the inner integral, in inner integral limit place we have x and y variable, then definitely it is a limit of z. Z varies from 0 to x plus y. Then in a limit place, since I have x variable and then we have dy in a second place, therefore this should be a limit of y. Y varies from 0 to x. Then the outer integral stands for x. X varies from 0 to a. Now keeping your x and y constant, integrate with respect to z. That is integral 0 to a, 0 to x, e power x into e power y constant, integral of e power z dz is e power z between the limit 0 to x plus y dy dx. Now apply the limit 0 to a, 0 to x, e power x into e power y remains as it is. Upper limit is e to the power of x plus y minus lower limit is e power 0 dy dx. Now simplify and then integrate. So integral 0 to a, integral 0 to x, e power x into e power x will be e power 2x. I can split this as e power x into e power y, right? So e power x into e power x is e power 2x into e power y into e power y e power 2y, and of course we know e to the power of 0 is 1, right? So 1 into e power x and e power y is e power x into e power y dy dx. So we remains with x and y variables now. Now keeping your x constant, integrate with respect to y. That is integral 0 to a, e power 2x constant, integral of e power 2y. Yes, e power 2y by 2 between the limit 0 to x. Then minus e power x constant, integral of e power y is e power y between the limit 0 to x into dx. Now before going to integrate, of course we have to apply the limit and simplify, then integrate with respect to x. That is integral 0 to a 1 by 2 common into e power 2x into upper limit is x. So in place of y, replace by x, e power 2x minus e power 0 lower limit minus e power x into upper limit is x. So e power x minus e power 0 into dx. Now simplify that. Integral 0 to a 1 by 2 into multiply by e power 2x. E power 2x into e power 2x is e to the power of 4x. We should add the powers, right? 2x plus 2x is 4x. Then 1 by 2 times of e power 0. E power 0 is 1. Therefore, minus 1 by 2 times of e power 2x. Okay. Next term, minus e power x into e power x is e power 2x. E power 2x minus of minus plus, e power 0 is 1. So 1 into e power x is e power x into dx. So I think we can simplify in one more step before going to integrate the next step. I can simplify these two. They are same with the different multiples. That means I have e power 2x common, minus 1 by 2 minus 1. So minus 1 by 2 minus 1 is minus 3 by 2. So integral 0 to 1, 1 by 2 times of e power 4x. If I add these two, we will get minus 3 by 2 times of e power 2x plus e power x between the limit into dx. Now integrate with respect to x. Of course, we remains with all the terms as x variables, right? Only we have x functions. Okay. So now integrate with respect to x. 1 by 2 into e power 4x is e power 4x by, yes, 4 between the limit 0 to a. Okay. And minus 3 by 2 times of integral of e power 2x is e power 2x by 2 between the limit 0 to a plus e power x integration e power x between the limit 0 to a. Now simplify, apply the limit 1 by 4 common, so that 1 by 4 into 1 by 2 is 1 by 8. Upper limit a e power 4a minus e power 0 minus 3 by 4 into upper limit a e power 2a minus e power 0 plus upper limit a and e power 0. So simplify this, e power 4a by 8, e power 0 is 1, so 1 into 1 by 8 minus 1 into 1 by 8 minus 1 by 8 minus 3 by 4 times of e power 2a, e power 0 is 1, so minus of minus plus 3 by 4 plus e power a minus 1, e power 0 is. So the next step is, I can simplify 1 by minus 1 by 8 plus 3 by 4 and minus 1, right. So your next step is, I is e to the power of 4a by 8 minus 3 by 4 times of e power 2a minus 3 plus e power a, and then if I simplify minus 1 by 8 minus 1 and plus 3 by 4 by taking LCM and simplifying, we have minus 3 by 8. So this is our required result. Next problem, evaluate triple integral dz dy dx divided by 1 plus x plus y plus z whole cube, and the limits are, the outer limit varies from 0 to 1 and the second one 0 to 1 minus x, and the inner limit between 0 to 1 minus x minus y. So consider the given integral as I, that is I is triple integral of dz dy dx divided by 1 plus x plus y plus z whole cube. Limits are 0 to 1, 0 to 1 minus x and 0 to 1 minus x minus y. So of course we should know what is the limit of x, y, z, right? Since in a inner integral place, in a inner integral the limit values are 0 to 1 minus x minus y, we have x and y variable in a limit place. Therefore, that should be, yes, that should be the limit of z. So, and also we have dz here. So, z varies from 0 to 1 minus x minus y. Then in the second one we have x variable. Therefore, y varies from 0 to 1 minus x. And then dx, therefore, x is a constant limit, x varies from 0 to 1. Now keeping our x and y constant, we should integrate with respect to z. So the given is reduced to this form, that is dz by some constant plus z whole cube. So integral of that is nothing but minus 1 by 2 times of a plus z whole square, because we know integral of z to the power or some function or some variable z power n is nothing but z to the power of n plus 1 by n plus 1. So in place of n, the standard result is this, integral of z power n with respect to z is nothing but z to the power of n plus 1 by n plus 1, right? So in place of n, we have minus 3 here, so that we have a plus z whole square or minus 1 by 2 times of a plus z whole square. So if I integrate this with respect to z, we have integral 0 to 1, 0 to 1 minus x minus 1 by 2 times of 1 plus x plus y plus z whole square between the limit 0 to 1 minus x minus y into dy dx. Okay. Now apply the limit, that is integral 0 to 1 0 to 1 minus x, minus 1 by 2 common. The upper limit is 1 plus x plus y. So in place of z, we should replace by 1 minus x minus y. So plus 1 minus x minus y whole square is the upper limit. Minus lower limit is 1 by 1 plus x plus y plus z should be replaced by 0 and we have whole square dy dx. So if I simplify, plus x minus x get cancelled, plus y minus y get cancelled, we remains with 1 plus 1 2, 2 square is nothing but 4. So integral 0 to 1, 0 to 1 minus x, 1 by 2 whole square is nothing but 1 by 4. 1 by 4 into 1 by 2 is minus 1 by 8. And of course this 1 by 2 minus 1 by 2 is multiple for the second term also. So minus of minus plus 1 by 2 times of 1 by 1 plus x plus y whole square into dy dx. Now integrate with respect to x, y keeping x constant. That is integral I reduced to integral 0 to 1 minus 1 by 8 constant, integral of dy is y between the limit 0 to 1 minus x plus 1 by 2 into integral of, now this looks like this, integral dy by some number or some constant a plus y whole square. So what should be the result? It is nothing but minus 1 by a plus y. The integral of that value is minus 1 by a plus y. So in place of a, we have 1 plus x. So the result is 1 by 1 plus x plus y between the limit 0 to 1 minus x dx. Apply the limit. So integral 0 to 1 minus 1 by 8 into 1 minus x, right, minus 0 minus 1 by 2 into 1 by 1 plus x plus 1 minus x, upper limit y should be replaced by 1 minus x, minus lower limit 1 by 1 plus x plus 0 into dx. So I can cancel plus x minus x here, and if I simplify, we have integral 0 to 1 minus 1 by 8 minus into minus plus x by 8, okay, and minus 1 plus 1 is 2, 1 by 2 into minus 1 by 2 is minus 1 by 4, minus of minus become plus 1 by 2 into 1 by 1 plus x dx. So before going to integrate, I can simplify one more step, that is minus 1 by 8 and minus 1 by 4, that is integral 0 to 1 plus, I write first positive term, that is x by 8 plus 1 by 2 times of 1 by 1 plus x, then the simplified result of minus 1 by 8 and minus 1 by 4, 8 is LCM, so I remains with minus 1 minus 2 by 8 is nothing but minus 3 by 8 dx. So we left with x variables. Now integrate with respect to x, that is 1 by 8 common, integral of x is x square by 2 between the limit 0 to 1 plus 1 by 2 into integral of 1 by x is nothing, we have 1 by 1 plus x, right. So integral of 1 by 1 plus x is log of 1 plus x between the limit 0 to 1 minus 3 by 8 into integral of dx is x between the limit 0 to 1. Now apply the limit. 1 by 16 into 1 minus 0 is 1, okay, 1 plus 1 by 2 into upper limit is 1. So 1 plus 1 is 2, log 2 we have, and lower limit is 0. So 1 plus 0 is 1, log 1 is also 0. So log 2 by 2 minus 3 by 8 into 1. Evaluated result is I is 1 by 2 times of log 2, okay. I can simplify 1 by 16 and minus 3 by 8 if I take a 16 LCM and simplify, we have minus 5 by 16 is our result. So the next problem, evaluate triple integral r into dr into d theta dz between the limit 0 to pi by 2 and 0 to a sin theta and 0 to a square minus r square by a. So consider the given integral as I. I is triple integral r dr d theta dz between the limit 0 to pi by 2, 0 to a sin theta and 0 to a square minus r square by a. Now we have d theta, dz and dr as a variables, right? So in a inner integral we have r in place of a limit, therefore it should be the limit of z. Okay, so your z varies from, so I rewrite the given integral as 0 to pi by 2. So your z limit, since in an inner integral limit place we have r variable, therefore this should be the limit of z, and of course we know theta stands for an angle, therefore theta varies between 0 to pi by 2, and then we have in a second integral place theta as in a limit place, therefore that should be the limit of r. So rewrite the above integral like this, integral triple integral r 0 to pi by 2 and 0 to a sin theta, and the inner integral varies from 0 to a square minus r square by a. So as we know this stands for z, therefore first we should write dz, then we have a sin theta, 0 to a sin theta, and this stands for r, then we should write dr. Of course the last or outer integral is 0 to pi by 2, that is theta limit, therefore we should write d theta. So we can rewrite that. Now keeping your r constant, integrate with respect to z. Integrate 0 to pi by 2, 0 to a sin theta, r constant, integral of dz is z between the limit 0 to a square minus r square by a dr d theta. Apply the limit, integral 0 to pi by 2, integral 0 to a sin theta r into upper limit a square minus r square by a, and of course lower limit is 0 dr d theta. Now simplify before going to integrate with respect to r. So I is integral 0 to pi by 2, integral 0 to sin theta r square r into a square by a. So we have r a square by a minus r into r square r cube by a into dr d theta. So now integrate with respect to r, that is integral 0 to pi by 2, a square by a is nothing but a, integral of r is r square by 2 between the limit 0 to a sin theta, right, between 0 to a sin theta minus 1 by a constant, integral of r cube, yes, integral of r cube is r to the power of 4 by 4 between the limit 0 to a sin theta into d theta. So we remains with integral 0 to pi by 2, a by 2 constant, apply the limit, a square sin square theta minus lower limit is 0, okay, minus 1 by 4a into a to the power of 4 into sin to the power of 4 theta, and of course lower limit is 0. So simplify this, that is integral 0 to pi by 2 a cube by 2 into sin square theta minus 1 time a get cancelled, a cube by 4 into sine to the power of 4 theta d theta. So I can separate the integrals, okay. So a square by 2 into integral of sine square theta and sine power 4 theta. This can be obtained by a standard reduction formula. Whenever we have a limit between 0 to pi by 2 with the sine to the power of n theta d theta, we have a standard reduction formula, that is n minus 1 into n minus 3 into so on divide by n into n minus 2 into etc. remains with 1 by 2 into pi by 2 when n is even. In the given problem, we have n even. So we have sine square and sine power 4. So I can apply that formula directly here. So that a square by 2 into, so in this case your n is equal to 2. So 2 minus 1 is 1 by 2 into pi by 2. And in the second, a cube by 4 into n value 4. So 4 minus 1, 3 into 1 divided by 4 into 2 into pi by 2. So if I simplify this, we have pi a cube by 8 minus 3 times of pi a cube by 64. If I take LCM as 64 and I simplify, we have our final result as 5 times of pi a cube by 64 is our required result.